data is Boston. Connect this to ggplot. In aesthetics, now we have to give X as well as Y, because in a scatter plot, you need two variables. So suppose I want minutes for each player on the X-axis, and I want points scored, so PTS, on the Y-axis. And then I can add another layer and specify geometry. So GEOM underscore. For scatter plot, we use GEOM point. So there's somewhat increasing trend. Okay, so this basic thing I can copy and paste again and show you, like you can do a few more things with this. A trend line using GEOM geometric underscore smooth. So if you run this, so it tries to actually capture the trend, not the linear trend, but whatever trend it sees, and also with some confidence kind of interval. But we don't need that kind of complication. If we simply want a linear pattern without any band, you can say within smooth, standard error is 0, and the method can specify as within quotes LM, linear method. So that will simply give you a straight line pattern running through the dots. Let me copy this and paste. Let me just make it clear what I'm trying to do here. I want scatter plot with two trend lines, X and Y specified, and then I can specify color, outcome, whether it was win or a loss. So as soon as we include a variable, like we want to separate them out, so it will give you a trend line, one for the win, one for the loss. And this is just for illustration. If you want to do a log transformation, you can add a line and simply say scale underscore. Suppose we want to do log scale for y-axis. So y underscore log 10. Variable gets transformed with the log scale. So I'm going to copy that code where we created EFG, effective field goal percentage. So I will use that, and we'll store this in object new. So just to see what we have in new, we have the players, we have EFGs, and how many games they have played. So I want to make a bar plot just with the new data. Connect this to ggplot, where we say aesthetics. And on the x-axis, we have player names, which is a factor kind of variable. So I can specify that I'm working with the factor, and the variable is name player. That's one, but for the bar plot, we need the values also. And that value I'm going to supply as y. If you look again under new, name is EFG. So that's what I want to say for y. Add a layer and specify like geometry, GEOM underscore. So bar plot, basically we use columns, COL. So the function we use for making bar plot is GEOM underscore COL. You get a bar plot, which may not be very meaningful because names are all jumbled up. You cannot really read any name. So in these situations, we can reverse actually. Instead of names being on x-axis, we can put on y-axis. You can simply say plus COORD coordinate underscore F flip. You can flip the coordinates so that the names are more clearly visible. If these colors are too dull, you can always add one more thing here that we used earlier, fill. So fill equals name player. So for each player, you can have a different color. Now in this bar plot, actually the legend is not really useful. So we don't need this. And you can specify that under GEOM underscore column show dot legend false. So false means don't show it. BOS, connect this to ggplot, aesthetic. So by now you'll see the pattern, the way we start and then customize it by adding layers. On x-axis, let's say I want players. For each player, I want how many points they have scored. So PTS. You can also specify color equal name player.
Professor, you forgot to add the equal after the Y.
Thank you. And then plus, then specify the geometry, GEOM underscore for box plot. If you run this, you get box plots, but I think same problem. So I'm going to just use this coordinate flip thing. And also we don't want this legend because there's no point here. So I'm going to copy paste for box plot 2. So as you know, box plot is a 5-number summary. The line in the middle is the median. And this is the first quartile. This is the third quartile. This is the minimum. This is the maximum. And then there could be some points outside which do not touch the box or the lines. So those are likely to be outliers. I'm going to copy this and just one variant of box plot, something that you may find very interesting. I'm going to keep it smaller because I don't want to do with the entire data. So I'm going to filter, only include those situations where minutes are at least 5. So a player at least was on field for 5 minutes. And under ggplot x-axis, I will remove this. Instead, I will put interaction and then say interaction between what? So I want interaction between player and outcome of the game. Let me use, instead of color, we use fill, outcome, game, and box plot, coordinate flip, all that. So let's see, what do we have? This plot is for all the combinations of player versus outcome of the game. So every player who played in a win, every player who played in a loss, and what kind of variability we saw in point scoring for each player in those situations. So I'll copy that code that I used for scatter plot, this one. So if you recall, this is the plot we got. This is the scatter plot. So I'm going to store this in this plot itself in P. So if I run this, you'll not get a plot, but it will just run the line. Then use gg marginal. So this is a function in package called gg extra that we loaded earlier. If you supply P to this, it will give you marginal plots like in the form of a curve. This is for the x-axis data points and this is for y-axis. Instead of curve, if you want, let's say histogram, you can do that too. Those histograms are basically called marginal plots. Sometimes we want to know what kind of pattern we have. Is it skewed, right skewed, left skewed? Is it normal? This is a quick way of doing this. And while you are doing this, you can also play with the colors. I'm going to create an object data where from the Boston data, I'm going to select only some specific columns, 32 to 34 and 37 to 40. You can actually check what are those columns. And using these columns, I can do COR or correlation matrix and supply the data that we just now created. It actually gives you too many decimals. You can say round COR data. I will use 3. That will be more compact. You can have a visual plot of this too by using CORR plot. Supply COR data within that. I will also customize this so that we don't have too much information. So for the type, we'll say we want upper only. So it makes this kind of plot. I'm going to include method. So instead of that circle that you see, we can say number. So you get correlation coefficients. Say number dot CEX. So if I say 1.5, it will increase the size by 50%. So certainly correlation, some correlations are high, like 2 pointers made versus 2 pointers attempted. Obviously, those are expected to be related. Same thing with the 3 pointers attempted versus 3 pointers made. So that correlation also seems to be quite high. Pairs dot panels. If you do that with the data that is a subset of the Boston data, the correlations that usually we get in R are Pearson correlations. But sometimes our data and the marginal distributions may not be symmetric, may not be normal. So in those situations, people suggest we should use Spearman because Pearson assumes there's a linear relation between the variables. But that may not be the case all the time. We may have non-linear relations, and also the marginal distributions may not be symmetric. So those situations call for Spearman rank correlation. And if the data is same, individuals are assessed by different judges, like in a beauty contest and things like that. So there we use end-all. And you can do that very easily in R. So if I say data method, instead of default Pearson, if I want Spearman. So you will notice that as soon as I run that, these numbers are likely to change because calculations will be different. This became 0.89. Earlier it was 0.67.